Hello wonderful person, this is Anton, and in today's video we're going to be talking about, well, can you guess? What is it that we're looking at? Well, this is actually yet another pulsar, another neutron star that's right in front of its partner, an orange dwarf. Now in this video we're going to be talking about not just pulsars themselves, but their features such as their sound that you can actually hear with various radio telescopes if you convert the frequency that they are emitting to more audible airwaves. In today's video I'm going to actually show you what pulsars sound like, or I guess I'm going to let you hear it. And we're also going to talk about the globular cluster that we're in, known as 47 Tucanae. Welcome to What the Math. So let me actually just escape this particular system and show you where we are right now. We are located in a very large globular cluster in our galaxy, or I guess just a little bit off our galaxy, known as 47 Tucanae. This particular globular cluster is very well known because it's kind of easy to see, there's nothing really around it, but also because it has a tremendous amount of really cool things in it, including, at least as of today, 22 millisecond pulsars. And these types of pulsars are actually really important for us for many reasons, including of course creation of various molecules and various atoms that don't exist without neutron stars, but also because they allow us to position things very precisely in space. But except for all of this, it's also kind of fun just to listen to them because their frequency is always very specific and it can be converted to audio waves. In other words, if you take the X-ray emissions that they basically produce and send toward our planet Earth, you can then change it to audio wave and listen to the actual sounds. Now, let me actually just show you some of them first. And all of these are actually real pulsars, really well-known pulsars as well. And this is coming from the Jodrell Bank Observatory from the University of Manchester. And so here we actually have quite a lot of various pulsars, and a lot of them are quite famous, but let's just take a look at some of the more famous ones, or let's just start with the first one, which might be not as famous, I guess. This is the brightest radio pulsar in the northern skies, and if you actually play this, by clicking this middle button here, this is what it kind of is seen as on Earth. Basically, about every second, there is a large pulse, and this is exactly why we call them pulsars. If you know the story behind this, back in the 70s, when we discovered these, we actually thought it was aliens, because what else could be sort of producing this? And it took years to figure out what this was. And turns out it was a neutron star. If you actually go through some of them, they look slightly different. They all have a very specific signature. Like, for example, this one will be a little bit different. And you'll see that its frequency and also what it's producing is very different, because it's a lot faster. Some of them are not as visible, like for example, if you look at Crab pulsar, which is the youngest pulsar known to us, it's only about 1,000 years old, it has these tiny pulses, they're barely visible. And this is actually a pulsar that we've originally detected back in 1024, I believe, year 1024, when the Chinese astronomers reported this bright flash in the skies that then created Crab Nebula. But the coolest ones are actually lower down, because that's where the frequency increases. And the one I actually wanted to show is a pulsar I briefly talked about in one of the last videos. This is the one that is one of the most accurate or accurately measured pulsars, with very specific location that we know, and also a very specific frequency that we are thinking of using as a new way of measuring time. And its frequency is 173 hertz, and that means that it spins 173.7 times per second. And this is what it's... And this is what it sounds like as well. A little bit annoying, I guess. It's a kind of a buzzing noise, but that's basically because it's the frequency of 173.7 hertz. And as you can see here, it's also a very old pulsar. It has a partner as well. It spins around this partner in a relatively circular orbit. But I wanted to really kind of focus on 47 Tucanae because it's such an interesting globular cluster. So there it is, sort of all by itself, with our galaxy being somewhere in the background. There it is. I'm just going to increase luminosity so you can see it better. And our planet Earth, in relation to all of this, is located right here. So at a distance of approximately 15,000 light years. Now, 47 Tucanae is essentially just a collection of stars together, but there's a lot of stuff here. There's a lot of various stars, there's a lot of different types of stars, and as a matter of fact, if you have Space Engine, and if you just go in the middle of this globular cluster, and then click on the search function, and try to find some of the pulsars here, within the 10 light years, you'll find quite a lot, quite a tremendous amount. This one here even has 8 planets around it. This one has 11 planets, and as you can see, there's tons of them. So we're gonna actually just stop this for a second, take a look at one of them. Now, the cool thing about this is that because they're kind of all clumped together, they're all very, very close to each other, and because this globular cluster is kind of far away from us, if we actually point our telescope at this globular cluster, what we'll actually hear is a collection of all pulsars kind of basically singing together. It's going to be like a symphony of pulsars. And I kind of want to actually show you what this looks like, because the University of Manchester actually created this really, really cool simulation of what it would sound like if all of these pulsars were heard at once. And the sound of these pulsars is actually right here. This is a simulation of 16 known millisecond pulsars with a frequency between 2 and 8 milliseconds, or basically periods between 2 and 8 milliseconds. In other words, they're relatively fast moving, fast spinning pulsars, and it all sounds like this. So it's a very eerie sort of a symphony, but here's actually a visual simulation that was made by Michael Kramer and Andrew Line that basically made the video that you can see right here as well. And this is sort of what all of this looks and sounds like. So somewhat maddening and somewhat crazy, but very, very, very interesting and actually almost beautiful in some way. Here's a more realistic version that also takes into account various fading effects caused by various stars, and it sounds like this. And you can check out the rest of the sound files on the website. It's in the link in the description below. But basically, that's kind of what all of this would sound like if we were to point our telescopes and convert all the frequency we receive to sound waves, because that's essentially how many pulsars we've detected here, and this is how concentrated all of them are here. It's a very interesting location. There's a lot of really cool things here. Definitely a lot more mysteries as well, and possibly even life somewhere, for all we know. And you can actually even try to see if there's life, at least in Space Engine, by searching for it using the same feature, using the same filter settings, and changing this to life. And let's see if we find anything. And there we go. Lots and lots of planets within 10 light years. A lot of different life here, even more so than neutron stars. Well, anyway, that's all I wanted to talk about in this video. I wanted to show you, and I guess let you hear, what pulsars sound like, and what this particular globular cluster has in it that makes it so unique, so unusual, and so interesting. In a sense, it's actually one of the coolest objects to study, because there is so much interesting stuff here, all in the same region of space. Other than that, that's all I wanted to talk about in this video, and in the next video we're going to talk about something else, so do come back tomorrow to learn something else, and subscribe if you still haven't. I'll see you guys tomorrow, space out, and as always, Bye bye.